Hello and welcome back to Atomic Adventures. In today's video we are going to be discussing ionizing radiation. I made a previous video about this, but I wanted to make one that was more in-depth, so here we go, enjoy. Ionizing, also called nuclear radiation, is radiation that carries enough energy to knock the electrons off of atoms. This is called ionization, and there are four main types: alpha particles, beta particles, gamma rays, and neutron radiation. Alpha particles are made of 2 protons and 2 neutrons. This form of radiation is the easiest to shield and the slowest moving. However, it is the most dangerous if it is ingested. Alpha particles, as you can see, are positively charged. Because they're positively charged, they'll steal electrons from your cells, which is why they're so dangerous. Alpha particles can be found from smoke detectors. Smoke detectors contain an americium-241 source inside of them, and that's how it detects the smoke. Something that you shouldn't really worry about, though, because the casing blocks all the alpha particles. But something that you should worry about is cigarette smoke. Cigarettes contain polonium-210, which is an alpha particle emitter, and when inhaled, that really damages your lung tissue and is why it's so dangerous to smoke. Next, we have beta particles. Beta particles are electrons or positrons, depending on their charge. These are much faster moving, they move at the speed of light, and they're more penetrating. Beta particles can be shielded by steel or aluminum, but alpha particles are a lot less penetrating, which can be shielded by paper. This type of radiation can be found in bananas. Bananas contain trace amounts of radioactive potassium-40, which is a beta particle emitter, but you'd have to eat over 100 million bananas to receive a lethal dose, and I think you'd have a lot more problems anyway. And then we have tritium. Tritium is a radioactive form of hydrogen, and it is used in things like military dials or other things that need to glow in the dark, such as exit signs, because it requires no electricity to glow. Next, we have gamma rays or X-rays, which are much more penetrating than the previous two, and need lead or concrete to be shielded. This type of radiation can be found in space from cosmic rays or from radium watches or any other radium-containing paints, as well as X-rays in the form of medical imaging equipment. X-rays and gamma rays are very similar, but X-rays are lower on the wavelength spectrum and they're less energy. And finally, we have neutron radiation, which is arguably the most dangerous type. Neutron radiation can only be shielded by a very thick layer of concrete. This radiation has no charge, so it can cruise through anything without any resistance, and that's why it's very detrimental. This form of radiation also can create radioactive elements by neutron bombardment, because adding a neutron, it'll make it unstable. This type is only found in nuclear reactors or for neutron irradiation and radiography for research purposes. There are many different ways we can detect ionizing radiation. There are 4 main types of detectors that are used. There's the Geiger-Müller counter, which, depending on the type, can count alpha, beta, or gamma radiation. Then we have scintillators, which can detect alpha, beta, and gamma radiation. Scintillators are neat because they utilize a crystal and a photomultiplier tube, and when the radiation passes through it, it emits light and is able to detect the different energies from the radiation. Then we have ionization chambers. These utilize a chamber, and they're not very sensitive. They can only detect high energy beta and gamma radiation. They're used for high radiation environments or nuclear disasters. And then we have neutron meters, which can detect neutron and sometimes gamma radiation. And they use a sphere filled with helium gas. I already did a video on radiological survey instruments, so I'm not going to go too in-depth on these. And the biggest concern with people when they hear radiation is safety. While radiation is very dangerous in high amounts, we're exposed to it every second of every day. And in the United States, we're exposed to about 620 millirem or 6.2 millisieverts per year, which is equivalent to about 155 chest x-rays. And this would vary from place to place. For example, if you lived in Denver, Colorado, you'd receive a much higher dose because you'd be exposed to a lot more cosmic and space gamma radiation from space because you're a mile above sea level. And same difference, similarly, if you worked on a commercial airline, you'd be exposed to a lot more cosmic neutron radiation because of how high you are in the atmosphere. And even if you worked in the Capitol building, surprisingly, the Capitol contains a lot of granite in its construction, which contains naturally occurring radioactive materials, which will also contribute to your dose. Thank you for watching this video, and I hope you enjoyed it, and please subscribe.